to do to kind of go get the compilers and get it installed onto your system. So thank you to Microsoft for that. And then our cluster computers in the dorms and the libraries and the lair have both of the Macs and the PCs have the compilers and libraries installed, so that if you actually just work in a cluster, you don't have to do anything special at all. You just walk up and it's got the stuff ready to go. Well, hi, you can't ask me that because, of course, I'm totally biased. I'm a Mac person. I've been a Mac person forever. So I can't get over the fact that you go to the Start menu to shut the machine down, and that makes Windows impossible for me to use. I would say, though, campus-wide, right, there's a mix of people. Probably there are more Windows machines than Macs on campus. So if you want to take a popular vote, you could do that. But if you want to be on the side of the Mac bigot, you can come be with me at Xcode. Xcode is a very nice compiler, but Visual Studio also seems perfectly serviceable. So, okay. All right. Well, look at this. I've got 10 minutes, maybe a little bit more, to tell you a little bit about C++. Because that is the next journey, right, that we're going to go on together. C++. So it's like the first question I'd say is, why are we doing this to you? You're like, I just got comfortable with Java, and now you tell me to throw away my Java and start over. Okay, so let's generate a little bit of love for the C++. Okay, I put this: the advantages of early multilingualism. So I have two small children at home that are 2 and 4. I read a lot about bilingualism and stuff, sort of raising your children in kind of a global world. And there's, very, very clear evidence for natural languages, right, that when you're acquiring a language, at those young ages, right, that is the best time to introduce a second or third language, where you're kind of building all the pathways in the neurons and stuff. There's some really very neat research there. And so the same thing has been looked at in terms of programming languages as well, that when you are learning a programming language, right, there are certain kind of ruts your mind gets into about the way a language is that is based on your experiences early on. And if you spend a very long time working only in one language, those ruts get deeper. And you have a certain way of thinking, right? You're kind of a little bit stuck in that paradigm and its approach. What's easy to do in that language, what's hard to do in that language, right? Tends to kind of make a stronger impression on you in a way that makes it harder as you grow and explore other languages to kind of get out of those ruts and kind of shake yourself out of it. And so there's been some pretty good evidence that that about 1/4, somewhere between 1 and 2, is a really good time actually to think about branching out a little bit and starting to think about different ways of doing stuff and seeing some different syntax and some different ideas to help kind of just build in the flexibility from an early age in your career to kind of buy you some strength later. So that's part of what we're doing. Some other part of it is actually that a lot of our upper division courses, right, rely on a knowledge of C and C++, that family of languages, and that the longer we postpone it, the kind of more painful it becomes. Because in the later courses, right, when you're learning about compilers or graphics or networking, they don't really have the time in those classes to stop and teach you C or C++, but they need you to know C++ to get the work done. And so it's like, where are we going to make sure you get this foundation? And sort of moving it into a programming class seems to make the most sense in the context of our curriculum. So we do switch you over here. The good news is, right, is that it's not as big a change as it might sound at first glance. To say I'm going from a totally different language. Well, Java actually is a highly derivative of C++ for a start, right? They're kind of cousins in the scheme of language design. And in fact, right, they have a lot of syntax. So I say, well, how much C++ do you need to know to start? Okay, here's the answer: 0, right? You don't even need to know what the word means, right? You can say C++, oh, okay, whatever. In fact, you actually probably know a surprising amount about C++ just by virtue of what you already know, just translated a little bit. That things like, let's say, the for loop of Java, or the way you declare variables, or the way the parameters are passed into a function, is exhibited in Java in very much the same way it is in C++. So there's a bunch of things you actually already know and you don't even realize it. But it is not assumed, right, that you know C or you know C++. If you happen to already know those things because you had your course or some of your background was in that, you're ahead of the game. If you have not, then not to worry. So what we're going to do is say, well, how much C++ are you going to learn, right? So we will spend the first, I think, 3 or 4 lectures just talking about how things get expressed differently in C++, and mostly actually talking about the differences in the libraries. That the syntax itself is quite similar, that some of the more extensive changes have to do with, well, how the C++ string is operated on versus the Java string. How you do file input-output reading in C++ is a little bit different than the way it's done in Java. So we'll spend some time saying, okay, well, here's some things you know how to express in one language. We're going to teach you how to express them in another language. So it's just mapping from your previous vocabulary onto a new one. Then along the way, we will actually introduce some of the C++ features that we need to support our pedagogical goals. So we'll be talking about how classes get designed in C++. We'll see how to use classes. We'll see how to actually define those classes. And we will be looking at things like templates, which is the C++ construct for doing generics that you've seen in Java. So how you can build containers that are type unspecific and things like that. We will learn a little bit of some of the fancier features of C++, like let's say the pass by reference parameter, but there's actually a very large amount of C++ that's just off the table for us. So we will not make extensive use of for example, the standard template library or the fancier features of static and const and a bunch of keywords, that mean nothing to you and should mean nothing to you. So you will learn, enough to I think have reading familiarity with C++ and to be able to express yourself quite well in the subset we're using. But it is a subset of C++, right, that you're being exposed to, and that there is. Oh, that's something I should have told you about in logistics, but maybe I'll mention it right here, right? Which is that if you find yourself really wanting to kind of master C++, right? You've got these programming techniques, but you're kind of curious about the other areas of language that kind of outside of our purview. We are offering cs106l. cs106l is a lab companion course that is open to students enrolled in 106b or 106x. It meets twice a week. It's actually on Monday, Wednesday, late afternoon. I think it's 4:15 in Hewlett 103. And it's being taught by a veteran section leader who is very well versed in C++ and who, in fact, kind of his own volition, kind of volunteered and created this course out of nothingness because he himself was a little bit frustrated as a prior 106 student and how wanting to get at some of those C++ things that really weren't fitting with our goals. So it is a place where you can get sort of just more exposure to standard C++, do a little bit of exercises that help you to test out those things and see how those things are expressed and get another unit. It's a pass-fail lab course. You can also just attend or just grab the materials if you just want to just look at them if it's not something you want to take the full commitment for. But a great way to just kind of broaden that knowledge of C++ beyond what's useful for us in terms of our goals. All right. Now I'm going to ask you some questions because I don't get to do all the talking. All right, so how much C++ do you need to know? Some of you may know nothing about it, and that is perfectly fine. But some of you probably know something about it, or at least have heard something about it. So I'm going to have you guys tell me what it is that, from an outside perspective, what it is that people tell you about C++ that seems to be, makes you either excited to learn it, or frightened to learn it, or interested in how it works. What do you know about C++?
What Java is based off of.
It is what Java is based off of. So that should be hopefully a little reassuring, right? That there's a syntax there that kind of got adopted with some minor changes. So in fact, right, that it should feel more familiar than different, at least when you look at it. So that's a very good thing to know, right? That it was very strongly influenced by a generation of programmers who C++ was their native language, right? Who designed the Java language. So that's a good thing to know. What else do you know about C++? Help me out.
It's extended C with object-oriented programming.
Yeah, so it's extended C. So here's how it kind of fits in the spectrum. It's like, well, C is kind of a 1970s creation, right? C++ is about a decade later. That C is the language in which it's based on, and in fact, it is an extended C. It's called a superset. That everything that compiles and works in C still exists in C++, but then they added a bunch of features. And not only did they add a bunch of features, they tried to fix some of the things about C++ by replacing existing things. For example, there's some string handling in C, but that's kind of very primitive. And so they added a string object with much cleaner handling and safer semantics into the C++, but they kind of left the old one around. So some parts of C++ that feel a little bit strange because of this history to it. The legacy of incorporating everything C was, plus this stuff, means at times there's a little bit of some weirdness there. But it also means that the language, as a result, is very large, has kind of a whole other language inside of it, plus this object-oriented, and a bunch of features way beyond object-oriented, in fact, right? Just tried to solve a whole bunch of other problems about, for example, C's type safety and runtime features, right, were kind of extended by what got added in C++. What else do you guys know? The other, 198 of you have never even heard of C++. Is that what I'm seeing?
A friend of mine told me that she could do things like type different things.
Yeah, that's a good thing to know. So you're hearing C++ might be a little more dangerous than Java, right? And that is true, right? It's not a wipe out your computer may be kind of a slight exaggeration of the situation there, but that Java as a family is very concerned with safety, and in particular since Java was designed for kind of this web delivery of content, right? It was very important that the program actually have very constrained features on what it can and can't do And so as a result, Java write tends to be very parental. You might have remembered from working 106a, it's like when you forget to initialize a variable, when you forget to return from a function, when you call a function with the wrong number of arguments, all these sort of things, Java's very aggressive about saying, hey, you got to fix this, I'm not letting this go. C++, a little less parental. Right? So maybe here's the kind of overly protective mom, helicopter mom, they call them at the park, the ones who kind of stand. That's Java. Java's making sure that, oh, are you okay, sweetie? Let me stand right here in case you fall. C++ is crack mom. She's like, yeah, I'm over here with my friends. Yeah, don't play with the kitchen knives, right? But then turns her back, right? And then, of course, what do the kids do? They're in the kitchen knives. So it has, it's a professional's tool, right? And professionals don't want to feel encumbered. There's certain things they want to do that require kind of some of this low-level access, and safety usually comes at a cost, right? Any sort of feature where the language is double-checking for you is taking time. It's taking efficiency, right? And there's a cost associated with that. If every time you went to go get something out of an array, it checked to make sure that that number was not off either end, then every array access costs you a little bit more. C++ says, I'm not going to charge everybody that penalty. If you actually have the bad sense to write a program that does those things, you deserve to be punished. And as a result, right, you will certainly at this time, at some point this quarter, kind of get to experience a little bit of that firsthand. Some of it is a growth experience, right? Let's say some of it can be frustrating, but it is sort of part of what professional tools often look like, right? Is they are making these trade-offs over efficiency, over safety that put more of the work back on you as the programmer to be a little more attentive on those things. So it does mean you can write programs, right, that crash in very spectacular ways, much more interesting and varied and dangerous than the kind of things you can do in Java. Good to know. Anybody have anything like exciting about C++, something they want to be able to do that they think C++ might be the answer to? You want to use pointers. You're going to get to use pointers. Pointers are really, really neat. And they're also very, very challenging. Pointers are these ways of building these very flexible and amazing data structures, the kind of things that we're going to try to build, right? At some point, they are going to be the only way to achieve those things well. So building these things called trees and graphs and lists, right, rely on having understanding and mastery of the pointer type. But the pointer type is complicated, and it's part of that danger thing, which is having access to kind of rearranging memory by virtue of addresses, right, just opens up a lot of opportunity for there to be kind of mistakes. Mistakes can be made in the passive voice that have consequences, and you will get to experience firsthand what that's like. There's joy in it because getting it right is awesome, and there are things that you can achieve that are really extraordinary with pointers, but when it's not working, it can be frustrating. So you're getting kind of a little bit of both. Anything else you want to know? You want to tell me? Yeah.
How do graphics compare to Java?
So it turns out C++ does not have a graphics system built into it. So Java is actually quite distinguished from the previous languages in the sense that Java really tries to solve all problems. That traditionally a programming language tends to have a set of libraries that have facilities for data management and files, reading and writing files, sometimes some networking, but they don't tend to actually solve application layer problems. That tended to be a different piece of technology. Some vendor, like the Mac OS, might offer a graphics library that was written in C++, but C++, the language, right, didn't have a windowing system or graphics system. So C++ does not have those features itself. So any C++ compiler you get, comes with these basic things about handling files and managing these type of data structures, but it does not come a priori with a bunch of graphics routines. That said, Windows and Mac and Linux and all these things have graphics routines, right, that are written in C++, but they're all different. And so to say what are they like relative to Java, they're all different relative to Java. So at least it's not standardized. And so but there's a wide variety of them out there, and they tend to have a lot of very impressive and different solved problems, right? Because C++ actually has a longer history than Java, right? That a lot of problems have been solved in C++ that are available to you too. So there's kind of a lot of existing code that, other than what you might think of as standard. All right, I was going to show you a C++ program, but you know what? What I'm going to do is I'm going to give you 2 minutes of free time, and that way we'll have goodwill. So I will see you on Friday, and we'll be showing some C++. And if you have questions about your situation, come and talk to me now. It's a good time.